Hi students, today we are going to discuss one of the important topic of chemistry and a fundamental concept of the chemistry, that is Zeeman effect and Stark effect. What is the need of this? As we already know in the before, Bohr atomic model. Some of the drawbacks of the Bohr atomic model is there. That is mainly Bohr atomic model explained only the spectra of atoms with only one electron. Means it failed to explain the spectra of atoms more than one electron species. That is the main drawback. So to explain about the structure of the remaining atoms which have multi-electron system, Zeeman and Stark tried to explain the Zeeman effect and as well as Stark effect by applying magnetic field and electric field. Why magnetic and electric fields are required? Why? Because whenever there is a charge is there, what kind of charge is present inside? To know that, we should require magnetic field. What kind of charge is there? What type of charge is there? To know that, we require the electric field. So that is the use of both magnetic and as well as electric fields. Let us discuss now what is the use of these fields and how they are discovered, that we will explain now by using different type of the topics. Let us see now. Consider this is main level. Main level 1, n is equal to 1, that is equal to k. So if we consider these are all the main levels, we already know main levels are represented by letter n. N is equal to 1, that is k level. N is equal to 2, L level. N is equal to 3, M level. N is equal to 4, N level. Now let us consider this is main level 1 and main level 2. N is equal to 2, that is equal to L. And this is main level 3. N is equal to 3, that is equal to M. And if you consider main level 4, that is n is equal to 4, that is n. By placing these main levels, which is represented by letter n, in the presence of the magnetic field, now these main levels are splitted into the sublevels. Main levels splitted into the sublevels, represented by letter L. Now, what are the sublevels are there under the spectra? If we consider main level 1 having only one sublevel whose L value is 0. This L value is 0 represented by the letter S. So here sublevel L is equals to 0 is called S sublevel. Wherever L is equals to 0, that is called S sublevel. Now come to the main level 2. This main level 2 divided into two sublevels whose L values are 0 and 1. This 0 represented by S, 1 is represented as P. Now consider L is equals to 1. L is equals to 1 is called P sublevel. L is equals to 1 is called P sublevel. And N is equals to 3 is called main level 3 divided into 3 sublevels. Their numerical values are 0, 1, 2. They are also called as S sublevel, P sublevel, D sublevel. That implies L is equals to 2, that is called D sublevel. L is equals to 2 is called D sublevel. Now, if you observe the main level 4, this main level 4 divided into 4 sublevels. They are 0, 1, 2, 3. So totally there are 4 sublevels are there in this. They are represented as 0, 1, 2, 3. As I already said, L is equals to 0 is called S sublevel. L is equals to 1 is called P sublevel. L is equals to 2, that is D sublevel. Whereas well as L is equals to 3 is called F sublevel. So totally main levels are divided into sublevels in the presence of magnetic field. This effect is called Zeeman effect. splitting of spectral lines in the presence of magnetic field is called Zeeman effect. Splitting of spectral lines in the presence of magnetic field is called Zeeman effect. See, main level 1 having the sub-level 1 represented by letter S, whose L value is 0. Main level 2 sub-levels are also 2. They are represented by SP, whose values are 0 and 1. Main level 3 divided into 3 sub-levels. There are SPD, where S represented by 0 and P value is 1, D value is 2. Main level 4 divided into 4 sub-levels. There are SPDF. Their L values are 0, 1, 2, 3. Now we are going to discuss about the Stark effect. Stark effect is nothing but the observing the structure of atom in the presence of electric field. Now we will apply what are the conditions in the electric field. In the electric field, these sublevels are divided into orbitals. Sublevels divided into orbitals. This means main levels divided into sublevels, sublevels divided into orbitals. Let us see how many orbitals are there in each sublevel. For example, sublevel S, that is L value is 0, having only one sublevel, that is S sublevel having one orbital. Only one orbital is present in the S sublevel. Here also S is there, so it has also have only one sublevel. Now L is equals to 1, that is called P sublevel. P sublevel have 3 orbitals, means there are 3 orbitals are there in the P sublevel. Now it will be divided like this. 3 orbitals. Now once again you observe here S sublevel having 1 orbital, whereas well as P have 3 orbitals. Then D have 5 orbitals. There are totally D sublevel. For D sublevel there are 5 orbitals are present. 5 orbitals. Main levels divided into sublevels, sublevels divided into orbitals. Now consider here there is S sublevel with 1 orbital, P sublevel with 3 orbitals, D sublevel with 5 orbitals, F sublevel with 7 orbitals. So here F sublevel divided into 7 orbitals. Now let us consider to the fourth step. After the orbitals, there are electrons are accommodated. This means main levels divided into sublevels, sublevels divided into orbitals. Then orbitals can accommodate electrons. Now main levels divided into sublevels, sublevels divided into electron. Orbitals accommodate electrons. Now how many electrons are there? The condition is each orbital can associate with 2 electrons. Maximum of 2 electrons are associated in an orbital. That is the rule. Later we may discuss why only 2 electrons are there in an orbital. Now let us come here. S contains 1 orbital, so it can accommodate 2 electrons. Now here also sublevel S with 1 orbital, so it can accommodate 2 electrons. Sublevel P with 3 orbitals, it can accommodate 6 electrons. Sublevel S, only 1 orbital is there, so it can accommodate 2 electrons. Sublevel P with 3 orbitals, so it can accommodate 6 electrons. Sublevel D with 5 orbitals, so it has a maximum number of 10 electrons it can accommodate. Now let us come to the S. Once again S orbital, S sublevel with 1 orbital, it can accommodate 2 electrons. P orbital, P sublevel with 3 orbitals, it can accommodate 6 electrons. D sublevel with 5 orbitals can accommodate 10 electrons. F sublevel with 7 orbitals can accommodate 14 electrons. Now, if you observe here, totally S orbital can accommodate 2 electrons. P orbital can accommodate 6 electrons, whereas well as D orbital can accommodate 10 electrons, whereas well as f orbital can accommodate 14 electrons. This means main levels divided into sublevels, sublevels divided into orbitals, orbitals can accommodate electrons. What does it mean? We can compare this one in the case of main roads, streets like that. In a street, houses are there, houses can accommodate with rooms, inside the rooms persons are there. Like that only, if we consider the street as a main level, our house becomes a sub-level, inside the house rooms are present, those we can compare the rooms with orbitals. Which we persons are staying in the house, we can compare with the electrons. This is the basic structure of Zeeman effect and as well as Stark effect, which is also called modern quantum theory or quantum mechanical model of atom, which mainly introduced by the Zeeman and as well as Stark effect to rectify the defects of Bohr's atomic model. In this case, main levels divided into the sublevels, sublevels divided into orbitals, and orbitals can accommodate electrons. Splitting of spectral lines in the presence of magnetic field is called Zeeman effect. Splitting of spectral lines in the presence of electric field is called Stark effect. Let us discuss this in the form of a table also. Now, let us discuss this in the form of a table, that Zeeman effect and Stark effect only in the form of table. Why? Because if you observe either our SCRT textbook or CBSE textbook or otherwise NCRT or ICSE curriculum, we may observe this type of tables. So let us discuss that. Here in the first column I wrote main levels. For example, say main level n is equal to 1, that is called main level. Next one, it is divided into the sub-level. So main level 1, sub-level is also 1, whose L value is 0, that is called S sub-level. The next one, orbitals. S sub-level can accommodate only one orbital. Only one orbital is there. With one orbital can accommodate 2 electrons. This one, okay, now let us come to that. N is equals to 2, that is equal to main level L. Main level L divided into 2 sublevels. What are they? They are L is equals to 0 is called S sublevel, L is equals to 1 is called P sublevel. Now, these sublevels again divided into orbitals. How many orbitals are there? S sublevel has 1 orbital and P sublevel has 3 orbitals. The total number of orbitals are 4. This can be written as 2 square. Let us discuss why I wrote 2 square. Now, here comes to the electrons. In the S sublevel, with 1 orbital can accommodate 2 electrons. Now, P sublevel with 3 orbitals can accommodate 6 electrons. Now, the total electrons are 8. This 8 can be written as 2 into 2 square. 2 into 2 square. Now, let us come to the main level 3. Here, main level 3, that is equal to N is equal to 3, that is equal to M. Main level 3 have 3 sublevels. What are they? L is equals to 0, S sublevel. L is equals to 1, P sublevel. Whereas well as L is equals to 2 is called D sublevel. Now, these sublevels divided into orbitals. What are they? S sublevel 1 orbital, P sublevel with 3 orbitals, D sublevel with 5 orbitals. Now, by adding this, total number becomes 9. This can be written as 3 square. Now, let us discuss the orbitals are split into electrons. I already said each orbital can accommodate 2 electrons. Basing on the rule, here 1 orbital, sublevel S with 1 orbital can accommodate 2 electrons. Sublevel P with 3 orbitals can accommodate 6 electrons. Sublevel D with 5 orbitals can accommodate 10 electrons. Total number of electrons are 18. It can be written as 2 into 3 square. Now, let us come to the main level 4. N is equal to 4, that is equal to N. Having four sublevels. They are L is equals to 0 S sublevel, L is equals to 1 P sublevel, L is equals to 2 D sublevel, whereas well as L is equals to 3 F sublevel. These sublevels again divided into orbitals. Now how many orbitals are there? S sublevel can accommodate with one orbital, P sublevel with 3 orbitals, sublevel D with 5 orbitals, sublevel F can accommodate 7 orbitals. The total number of orbitals are 16. It can be written as 4 square. Now we already said that orbitals are accommodated with electrons. Each orbital accommodated with 2 electrons. Now one orbital, 2 electrons, 3 orbitals, 6 electrons, 5 orbitals, 10 electrons, 7 orbitals, 14 electrons. Total is 32. It can be written as 2 into 4 square. These are all the models what we already given in the early. That means main levels divided into the sublevels, sublevels divided into orbitals, orbitals can accommodate electrons. Yeah, students, now here we are going to learn what is this 2 square, 2 into 2 square, 3 square, why I wrote like this. If you observe here, main level 2, here I wrote 2 square. This means it gives the relation between number of main level and number of orbitals. Main level 2, number of orbitals are 2 square. Main level 3, number of orbitals are 3 square, it becomes 9. Main level 4, number of orbitals are 4 and it becomes 4 square, that is 16. Now general representation is, here 1 is there, it can be represented as 1 square. Now if n is the main level, n small n is the main level and the number of orbitals are becomes n square. That is n square is the formula for the number of orbitals that are present in a principal energy level or otherwise main level or main shell. Then what is this? This can be written as 2 into n square, here also 2 into n square, here also 2 into n square, here also 2 into 1 square. What is this representation? This 2n square indicate the number of electrons that present in a given main level, that is n. If n is the main level, 2n square is the formula for number of electrons that present in the main level. N square is the formula for number of orbitals, 2n square is the formula for number of electrons that are present in a given principal level or given main level. Now let us discuss G-man effect and Stark effect, which was explained by Bohr and Bury in the form of Bohr-Bury model. Here also same procedure only. Here, where at the center of an atom, if we consider these are all in the form of concentric circles. At the center of atom, both protons and neutrons are there, which is called nucleus, and the electrons are present in the main levels. As we already know, main levels divided into the sublevels. Those sublevels, main level 1, sublevel is also 1, represented by letter S, whose L value is 0. It accommodates 2 electrons. One electron is in the upward direction, another electron is in the downward direction. That is in the clockwise direction and as well as in the anti-clockwise direction. Now come to the main level 2, divided into 2 sublevels. Those sublevels are S and as well as P. Sublevel S, whose L value is 0, sublevel 1, L value is 1. Sublevels are divided into orbitals. S contains only 1 orbital, whereas well as P with 3 orbitals. Now this is like this, we should draw the orbitals. Then final one is electrons. every orbital can associate with 2 electrons. Regarding that principle, S can accommodate 2 electrons. Then comes to the P. P should contain 6. 1, 2, 3, 4, 5, 6. Like that only we should arrange by following certain rules. Mainly that rule is called Ohm's rule. Let us discuss what is the Ohm's rule in the next videos. Now let us see n is equal to 3, that is equal to capital M divided into 3 sublevels. There are S, P, D. S, P, D. For S, whose L value is 0. For P, L value is 1. For D, L value is 2. Then we should know the orbitals. S can accommodate 1 orbital. P can accommodate 3 orbitals. D with 5 orbitals. Now, after writing the orbitals, we should write the electrons. Each orbital can associate with 2 electrons only. So here 2 electrons are there. P with 6. 1, 2, 3, 4, 5, 6. D with 10 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, main level 4 divided into 4 sublevels. We already know that is S sublevel with L is equal to 0, P sublevel where L is equals to 1. Next one, D sublevel whose L value is 0, and as well as F sublevel where L is equals to 3. Here S with 1 orbital, P with 3 orbitals, D with 5 orbitals, F with 7 orbitals. Now we should accommodate the electrons. With 1 orbital can accommodate 2 electrons. With P orbital can accommodate 6. 1, 2, 3, 4, 5, 6. D can accommodate 10 electrons. 1, 2, 3. Now F can accommodate 14 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now observe, I am going to give the formula for number of orbitals. Main level 1, orbital is 1, so that can be written as 1 square. Main level 2, the number of orbitals are 4, 1 from S, 3 from P, so it can be written as 2 square. Here main level 3, the number of orbitals are 9. How? 1 from S, 3 from P, 5 from D. Total number of orbitals are 9. This 9 can be written as 3 square. And comes to the main level 4, the number of orbitals are 16. How they came? S1, P3, 5 and as well as 17. So totally it becomes 16. 16 can be written as 4 square. So here n square is the formula for number of orbitals in a given principal energy level. Now the number of electrons here, the electrons are 2. Here maximum number of electrons are 8. It can be written as 2 into n square. Here the maximum number of electrons are 18. That is nothing but 2 into 3 square. Maximum number of electrons are 32. Can be written as 2 into 4 square. The general representation is 2n square. So 2n square is the formula for maximum number of electrons that present in a principal quantum number or otherwise a principal energy level. This total topic was explained by Bohr and Burri, nowadays which we are following in a very familiar manner to explain the structure of atom and at the same time electronic configuration of different kinds of atoms. Thank you.